pull out my black book. Black book physics.
And in this problem, we have a child, and they're going to slide a sled down a hill and collide at 5.6 meters per second into a stationary sled that is identical to his. The child is launched forward at the same speed, leaving behind the two sleds that lock together and slide forward more slowly. What is the speed of the two sleds after this collision? So we have a collision problem. Nice thing about collisions, we don't have to worry about direction so much. We just have two things colliding. In collision problems, we always want to draw a picture, and you want to draw a picture of the initial stuff that's going on and the final stuff. So let's draw all of these situations. In the initial situation, we have a kid. There's my kid. Kid is on a sled. We have a total mass of the kid in the sled that's equal to the mass of the kid plus the mass of the sled. And we know that they are traveling initially at 5.6 meters per second. And we'll call this mass 1 and initial velocity of the first thing. And they're sliding down this hill, and they're going to hit something. The thing they're going to hit is this other sled. Mass 2. What is mass 2? What is the mass of the second sled? Same as the sled that the kid is on. So that is also going to be mass of sled. Okay? And how fast is that second sled going?
Stationary.
Stationary. So what's
0.
velocity 2?
0.
The initial 2 is 0. Okay, so that's what's happening initially in this problem. And then the final situation, what do we have? The final situation. Is the kid still on the sled?
Slide forward more
No.
slowly.
They smacked into the sled and the kid went flying. So the kid's flying away. Screaming. Flying along. Okay? So we'll call this mass 1 final. And how big is mass 1 final? Just the kid. So that would be mass of the kid. And then how fast is the kid going?
The kid is hard for the same speed. They were behind two sleds that locked together.
Same speed. Same speed as they were initially going. So how fast was the kid going initially?
5.6.
5.6. So how fast is the kid going final? 5.6. They're maintaining the same speed. 5.6 meters per second. Is that the only thing that's moving in the final?
No.
Nope. What happened to the two sleds?
They collide.
They collided and stuck together. And they're moving now. So I have, in the final situation, I also have these two sleds.
Being that it's stuck together, is that considered a perfectly inelastic collision?
Yep. All right, so in the final situation, we have, we'll call this mass 2. How big is mass 2?
Sled 1, sled 2.
Sled plus sled. 2 sleds. So 2 times the mass of the sled. And how fast is this going? That's what we want to know. This is what we're looking for. Okay, so we've drawn a picture of the initial situation and the final situation. And you should do this in all momentum problems. It helps you keep straight what's going on. And the other thing in momentum problems, what do we know about momentum? Does momentum change? No.
Unless the mass doesn't change.
Unless something comes in and outside stuff works in your system, momentum is conserved. So the momentum that I have initial has to be equal to the momentum that I have final. So the initial mass that I have in a system times the initial velocity has to be equal to the final mass times the final velocity. Okay, so what do I have going on initially? How many different things do I have in the initial situation? I've got the kid and the sled, so that's one package deal, and then I have the sled. That's another package deal. So I'm going to write both of those. I'm going to write mass 1 times initial velocity of system 1 plus mass 2 times the initial velocity of system 2. Yeah? Does that make sense? And that has to be equal to the final situation, where I have mass 1 final and V1 final plus mass 2 final times V2 final. Because I have a kid and a sled initially, and then I have, in the final situation, I have a kid, and then I have 2 sleds. So 2 systems, initial and 2 systems finally. Mass 1. Mass 1 I can plug in was equal to mass of the kid plus the mass of the sled. Mass of the kid plus mass of the sled times V initial 1. 5.6. I'm going to leave it as V01. I'm going to leave the variable in there. There is a reason I'm leaving that variable in there. Plus mass 2. What is mass 2 initially? That's mass of the sled times V initial 2. And that has to be equal to mass 1 final. What's mass 1 final? That's the mass of the kid times V1 final plus mass 2 final, which is 2 times M sled times V2 final, which is what I'm looking for. Okay, I'm going to distribute everything in so that I have everything as individual little equations. So I'm going to distribute that V initial 1 into mass kid. So I'm going to have mass kid times V initial 1 plus mass sled times V initial 1 plus mass sled times V initial 2. So that's everything that's happening at the beginning. And then that's going to be equal to mass of the kid times the final velocity of the kid plus 2 times the mass of the sled times the final velocity of the sled. Any questions on this point? So what I can do now is I can start getting everything that I need to find by itself. What am I trying to find here? I want to find V2 final. So I need to get that alone. So I need to do algebra. What do I do first? Subtract. Subtract M kid times V1 final to the other side?
Yes.
Okay, so we have M kid times V initial 1 plus M sled times V initial 1 plus M sled times V initial 2 minus M kid times V1 final equals 2 times M sled times V2 final. Divide both sides by 2 M sled. And I get M kid times V initial 1 plus M sled times V initial 1 plus M sled times V initial 2 minus M kid times V1 final. All of that divided by 2 times M sled equals V2 final. So this is my final answer, hopefully. All right, let's see. Now I can start plugging in numbers. This is as far as I could go until I plug in numbers. If you forget a calculator for the next exam, you can do this. You can get to this point. Okay? And get a lot of credit. All right, so let's plug in some numbers. Mass of the kid. Do I know what the mass of the kid is? Nope, we don't know what that is. Damn it. Do I know the kid's initial velocity?
Yes.
What is that?
5.6.
So mass of the kid times 5.6. Plus mass of the sled. Do I know the mass of the sled?
No.
Do I know the initial velocity of the sled?
Yes. The second one or first one?
First one.
5.6.
5.6. Because it's going the same speed as the kid. And then we have the second sled, plus the mass of the sled. Initial velocity of the second sled is? 0, because it's not moving. So that will go away. Minus the mass of the kid. What's the final velocity of the kid? 5.6 equals V2F. And we still need to remember to divide that left-hand side by 2 times mass of the sled. Hopefully some stuff is going to cancel out. Can I cancel anything out? I can get rid of the M sled times 0. Right, that goes away. Can I get rid of anything else? M-kid times 5.6 minus M-kid times 5.6 means that goes away. Those two cancel out to give me 0. Anything else I can cancel out? So now I've gotten rid of all of this stuff. That doesn't exist anymore. All of this stuff is gone.
Can you cancel out the 2 M sleds and just divide 5.6 by 2?
So exactly. I have now M sled times 5.6 divided by 2 times M sled. That is equal to V2 final. Mass of the sled cancels with mass of the sled on the bottom. And I end up with 5.6 divided by 2 equals V2 final. So V2 final, 5.6 divided by 2. Plug that into your calculator. 2.8. 2.8 what? Meters per second. How do we know that?
Because it's velocity.
Because it's velocity. And what do we do with our final answer? Box it. You will lose points if you do not circle your final answers, and you will lose points if you don't put units in your final answers. The units thing is super important, and you should lose points for that. The boxing thing is me being a little bit picky, trying to make my life easier. And also do me a favor, because some of you do work really, really weird and write your stuff all over the paper. You don't follow any kind of organization. So kind of try to put, okay, this is my answer to 100 part A. So specify that that's your answer to that part of the problem so that I don't have to guess. I will guess, but try to make my life a little easier. Okay, so that's 2.8 meters per second for V2 final. Any questions on that?
Actually, it was